Hello, pre-calculus classes. I have prepared some, and we're going to go over your assignment that I gave you last time. So everybody get out your assignment on 1-1, and I am going to help you out with some of the problems. I am at a workshop today, and so you guys are going to watch this video of this lesson, and Mrs. Harris, the substitute teacher, it's still Mrs. Harris, she is going to be able to pause this whenever you need to if I'm going too fast. I actually went through and did this all once, and then I realized my sound wasn't on when I was all done, so I got to do it over again. So I've gotten it all written up here, and which is going to make it a lot faster than when last time I did it, but it's probably not going to be as helpful to you. I will try and use my markers and everything to point out what I'm talking about. But what we're going to do is I'm going to do a couple of problems on this assignment that will help you out. I'm going to start off with number 17. So if you go to number 17, the instructions for 17 says, write each relation as a table of values and as an equation. So what I've done right here is I've written up here table, equation, and it wants us to graph it as well. So we're going to do all three things. We are going to write a table, graph, and equation. Says number 17 says the domain is all positive integers less than 10. Well, an integer is a whole number. And since it's positive, it can't be negative, so there's not going to be any -1, -2, or anything like that. And it has to be less than 10, so my domain is going to be these numbers 1 through 9, because those are the positive integers less than 10. And then it says the range is 3 times x. Well, that means whatever x is. In this case, like here, I have 1 for x. I times it by 3, and I get 3 over here. Okay, so 1 comma 3 is on my graph. Well, that makes it easy to write the equation. Right over here, y equals 3x is my equation, because y is going to be 3 times whatever the domain is. And so I can go through here. I can start at 2. And I can put 2 in for x. 3 times 2 is 6. And so I get this 6 right here. So 2 comma 6 is on my graph. And I can continue doing that. Put in 3. 3 times 3 is 9. So I get 9 for my range number over here. So I can get my range numbers by timesing the x number by 3. Then I went ahead and made a graph over here. My scale for my bottom isn't going up in 1s and 9. But I made my scale going on my y-axis in 3. So 3, 6, 9, 12, 15, 18, 21, 24, and 27. And I plotted the point 1 comma 3, then 2 comma 6, and then 3 comma 9, and 4 comma 12, and so forth. So, and then we get this line that goes up like that. Okay? Actually, we shouldn't draw the line in there because this is a discrete function. They're integers, so I should just put the points. 1 comma 3, 2 comma 6, 3 comma 9, and so forth. Okay, that's problem 17. I'm going to go to problem 22. Like I said, I already did this, so I have them all written out there. Okay, 22. I'm going to do 22, even though it's not on your assignment. 21 is the only one on your assignment. I don't want to ruin that for you guys. You guys need to practice. So, number 22. I'm sure you guys all appreciate that. So, it says 2, and in this one it says state each relation as a set of ordered pairs. So in 22, notice the table had 4 and 0, 5 and 1, 8 and 0, and 13 and 1. So right up here, I've stated these as ordered pairs. I wrote them out, 4 and 0, 5 comma 1, 8 comma 0, and 13 comma 1. And then it asked me to state the domain and the range. So the domain is 4, 5, 8, and 13, just the x numbers. And the range is 0 and 1. Notice that 0, 1, 0, 1. I don't need to repeat putting 0 and 1 down. So the range is just 0 and 1. I'm not sure why I have that -3, -2 there. Oh, I remember. If you look at 23 and 25, 23 is 4 points. This is 23 and 25 do the same way as 22. It's just that it puts the points on a graph rather than in a table. So like -3, -2 is the first point on number 23. And then you got points -1, comma 1, 0, comma 0, and 1, comma 1. So you write those down, state the domain and range of those, okay? Go to problem. Remember, you can pause this at any time if I'm going too fast and you need to rewind it or something to understand the problem. 27. Okay, 27 says given that x is an integer. Okay, once again, x is a whole number, an integer. State the relation representing each equation by making a table of values, then graph the ordered pairs of the relation. Well, it gives me two pieces of information. First of all, right up here, it gives me equation y equals -x. Then it also gives me, it tells me that 1 is less than or equal to x is less than 7. All that is saying is that x is a number between 1 and 7. But it also includes number 1 because we have this less than sign underneath the, we have this equal sign underneath the less than. So that says 1 is less than or equal to x, or if you read it right to left, it would be x is greater than or equal to 1. So we have all the integers between 1 and 7, including 1. So I come over here to my table. Everybody come over to the table now. It says to make a table. I start with all the numbers between 1 and 7, including 1, and I right here, 1, 2, remember they're integers, so it's only the whole numbers. I don't put 1.5, 3, 4, 5, and 6. Notice I don't put 7 because it does not include 7. That's just a less than sign. And then I plug each one of these domain numbers right here into the function. Y equals a -x. Well, if I put 1 in there, that means y equals a negative, and then in parentheses 1. Well, if I simplify that, that's just a -1 that I put right here. Then I put 2 in there, and that's going to give me -2, and 3, and it gets me -3, and 4 gives me -4, and 5 gives me -5, and 6 gives me -6. If I go over to the graph, I have my points that I graph. 1, -1, 2, -2, 3, -3, 4, -4, 5, -5, and 6, -6. And there's my graph. So that's what it's wanting you to do on problems 27, 29, and 31. I'm going to give you a hint on 31. Those are absolute value signs around 2y. And notice it gives you the value of x. X is 4. So if you put x in for 4, it says the absolute value of 2y equals 4. Well, I want you guys to think about this. 2 times what number, and then you take the absolute value of it, is going to give you 4. So I'll say that one more time. 2 times what number, and then take the absolute value of it, is going to give you 4. And I'll give you a hint. Y can be 2 different numbers. So think about what y is going to be on that. That's number 31, okay? All right, now we're going to go on to the next problem. On to problem 34. Okay, on this one it says, state the domain and range of each relation. Then state whether the relation is a function. Write yes or no. Well, if I go to 34, notice 34 is not on your assignment, but 33, 35, and 37 are similar to it, and they are on your assignment. I've listed all the ordered pairs up here for this thing, the 4, -2, 4, 2, 1, -1, 1, 0, and 0, 0. You will notice that when I state the domain and range of this thing, that there's 3 different range numbers. There's 4, but 4 is listed twice. There's 1, it's listed twice, and then there's 0. Okay, so my domain is just 4, 1, and 0. Whereas my range numbers are the y numbers, -2, 2, -1, 1, and 0. And this is not a function, so I'm going to put no. Remember, it's yes or no, whether it's a function. The reason it's not a function is because 4 is listed twice, and 1 is listed twice. Now, that only pertains to the domain. If an x number is listed twice, then this is not a function. The reason being, for example, if I take this right here, 4 comma negative 2, and I graph that point, 4 comma negative 2 is this point right here. I'm making it bigger. And 4 comma 2 is this point right up here, making it bigger. Notice that they don't pass the vertical line test. The vertical line goes through both of them. So that's why when the x number is the same, it can't be a function. So, but that's not true for range. Range can be listed more than once. So that's how you do problems like those. Okay, go to problem 42. Once again, I'm going to let you guys practice this yourselves, but 42 is you're learning how to use function notation, evaluating a function. And notice it gave me a function g of x right up here. G of x is equal to 5x squared plus 3x minus 2, and it tells me to find g of negative 2. All that means, if you don't remember, is to plug negative 2 into the function. So I have taken negative 2 and I've plugged it in for x. So 5 times negative 2 squared. 5 times negative 2 squared, 3 times negative 2, and minus 2 right there. So order of operations says I do parentheses first. I've written order of operations over here for you, if you haven't seen that. It's also on the back wall right behind you in colorful, on a colorful poster. Please excuse my dear Aunt Sally, P-E-M-D-A-S. Please excuse my dear Aunt Sally, or PEMDAS. And all it's saying is to, order of operations, to do parentheses first, then exponents, then multiply, divide, add, and subtract. So notice that the only parentheses up here, everything inside of them are already simplified. So I go on to the next one, which is to raise this to an exponent of 2. So I raise negative 2 to the second power before I times it by 5. It would not be correct to times 5 by negative 2 first. So negative 2 squared is 4, and 5 times 4 is 20. 3 times negative 2 is negative 6 minus the 2. Okay, so, after exponents came multiplication, and now we don't have any divide. We go on to add and subtract. Add and subtract, you just do left to right. So 20 plus negative 6 makes 14 right here. And then 14 minus 2 makes 12. And there's your answer right there. So keep that in mind. Okay, so you could have just watched that one. You didn't have to do it because it was an even number. Just study it. If you need to pause it and look at it, go ahead. Okay, number 44. 44, notice they give me j of x equals 1 minus 4x cubed as my function. That's right here. It wants me to find j of 2a, which is right here. So that means I'm going to plug 2a in where there's an x. So I did that right here. More specifically, there's my 2a that I plugged in for x. In following order of operation, I can cube both the 2 and the a since they're both inside. Well, 2 means, right over here, I wrote it 2 times 2 times 2, which is 8. So now I have 1 minus 4, parentheses, 8, a to the third power. Since a is a variable, we just have to write to the third power. Then I can multiply 4 times 8 because 8 no longer needs to be raised to a power, and I get negative 32. So my answer is 1 minus 32a cubed. Okay, now there's some other problems on this assignment. I'm not going to spend any more time on them right now. I'd like you to try them if you can. This next worksheet we're going to do might help you out with some of those. And you might be able to get them, but we'll talk about those more next time. So what I'd like you to do right now is get out that worksheet called Conquering Domain and Range. If you have not gotten it yet, pause this thing and hand them out. Also, you will need 2 colored pencils. Doesn't matter which 2, but they need to be different colors. And you're going to designate one of them as domain and one of them as range. You will notice that I'm going to use blue for domain and I'm going to use red for range. So go ahead and get your colored pencils if you haven't, and designate one as domain and one as range. Okay, what I'm going to do is, first of all, I'm going to do problem number 1 on this worksheet. Problem number 1. Problem number 1 looks like this graph over here. This black thing is the graph. And I've already colored it in, but since this is a continuous line, it goes forever left and forever right, my domain is all real numbers. So what I'm going to do is I'm going to color the domain in along the blue axis. I colored it in already once. I'm kind of doing some more right now because it's all real numbers. And I write for the domain over here, I write all real numbers. There's a spot for it on your worksheet, right? Because this graph stretches forever left and right. Well, looking at the range is how far it goes up and down, or the y values. Well, it goes forever up and forever down. So the same thing, I color in the y-axis where the range is, and it goes forever up and forever down. Therefore, my range is all real numbers. Once again, okay, because it goes forever up and forever down. Remember, you can pause this if I'm going too fast. I'm going to go to the next problem. Okay, problem number, it's the next one over, number 2. Okay, notice on this one, I'm going to have to erase this and redo it again. But notice that my points were at -3, -2, which is right here. Then at 0, 1, and 2, 0, and 4, 2. Okay, starting off with my domain. My domain, all I have to do is go to this point at -3, 2. Well, its x number is -3, so on the x-axis I color in -3. Okay, I go to the next point at 0, 1. Well, its x number is 0, so at 0 along the x-axis I color a blue dot in. I go over to 2, 0. Well, 2 is the domain number for that, so it's right on top of that point. So I'm going to color that point in blue. Then I go over to the point at 4, 2. Its next number is 4, so I color that in just below it. Notice that you just either had to go up or down until you hit the x-axis for the domain. Okay, the range, and I've listed the domain right over here: -3, 0, 2, and 4. Okay, the range. I'm going to have to just go left and right until I hit the graph, but notice that -3, -2, the range number is at -2. So I color that in along the y-axis. My next point was the one at 2, 0 that I covered up with a blue dot, but its y number was 0, so I colored in right there. So I have both the domain and range right there. Then this one right here is at 0, 1. So I color that one in, and this 4, 2 is at 2, so I color that one in. So my domain is -2, 0. My range is -2, 0, 1, and 2. And that's how you would do problem number 2. If you need to rewind and listen to that again, do it. Okay, going on to, oh, by the way, going back to this one. This one's called a discrete function, remember? Because it is made up of just points. It's not continuous like the first one that is, you just put your pen on it and you don't have to lift it again to draw it. But number 2 is a discrete function because it's made up of a finite number of points. Number 3 is also a discrete function. It's made up of it's made up of points. However, the points go on forever. So you still call it discrete. It's just that it's not, there's breaks in between. It's not continuous. You can't put your pencil down and just draw a line. You have to go to each dot and draw them. So it's a discrete function. Notice that it's on the integers, and it goes forever. Those little dots at the end mean it goes forever. So I'll let you guys think about that one. How would you do that one? Okay, go to the 4th one. It looks like this function right here. Okay, now I'm going to erase the domain and range I put in here. So we can talk about it right here, but the domain of this one, this thing stretches left and right forever, so the domain is all real numbers. It's continuous, okay? So we color in the domain this way. Put arrows on it, meaning it goes on forever. And I write all real numbers over here. My range, notice my range is only between -5 and +3. The graph does not exist above 3, and it does not exist below -5. And this is how I write it over here. I write it like this. -5 is less than or equal to y is less than or equal to 3, meaning that y is a number between -5 and 3, including -5 and 3, because I have those little equal signs under them. Okay, but that's how you write it when it's in between something. Put the y in between -5 and 3 and put two less than signs. Okay, so it only exists between -5 and -3. Nothing exists above 3 or below -5 on the y-axis. Next one. Okay, this one right here. I'm going to erase this one and do it over again. Okay, this one right here is at the very bottom middle of the page. It goes up to 4 and down to -3 and out to -2 and +2. It's just a diamond shape. Okay, and this one right here is not a function, by the way, because it doesn't pass the vertical line test. A vertical line going through that diamond would intersect it twice. And a function can only be intersected once. So this one's not a function. So, it's not a function. So, the domain of this one, the domain only exists between, whoops, I got the wrong color. The domain only exists between -2 and +2. The graph only exists between -2 and +2. It doesn't go out to 3, 4, 5, 6, or it doesn't go to -3, -4, -5, -6. It ends right there. So notice that I put x is a number between -2 and +2. Once again, x between the 2 and the -2 and 2. The smaller number always goes on the left, the bigger number on the right, and two less than signs. And my range goes up and down from -3 to +4. Okay, it only exists between -3 and -4, so once again I wrote it over here. Y is a number between -3 and -4. It includes a -3 and -4. You'll notice that 9 is similar to that. Oh, I'm just going to point out the problem right in the middle of the page, number 5, and the last problem, number 9, both have scales of 12 rather than 6 like the rest of them. If you'll notice, they go out from -12 to +12, -12 to +12. So keep that in mind when you are doing this. Okay, turn the page over. I am going to do the first problem on the other side. And I'm going to erase this really quickly here so you can see when I'm drawing it in. Okay, starting off with the domain. This right here is not a function again either because it doesn't pass the vertical line test, but it still has a domain and range. And the domain of this one, this thing goes forever left and forever right, so my domain is all real numbers going left and right. So colored in blue along the little x-axis. My range, however, only exists, this graph only exists from 2 and up, and from -2 and down. Okay? That's where it exists. So, it doesn't exist everywhere. So, whoops, I have this too high. Should have drawn the graph. Here's -2 down here, right? So this graph exists between, or from -2 and down this way. So, this is the way we write it over here. Y is greater than or equal to 2, that would be up here. And y is less than or equal to -2, and that would be these numbers right here. Notice that there is in between right through here, there's no part of the graph exists between -2 and +2. Just does not exist. Okay. That's all of them I'm going to do. What I would like all you students to do right now is if the substitute will assign each table, each pair of you, to do one of the remaining problems. And there might have to be two people on one problem, or two tables on one problem. We'll just see. But I want you to assign a problem, and then you've got to figure out that problem, and you got to come up here and show everybody what you got, and have a discussion about it. You're probably not all going to be correct, but it'll give you a chance to discuss it out loud with each other and see if you can come up with the right answer. And then on Wednesday, when I'm back in class, you guys can ask to see if you did it right, and we can have a discussion on it then. Okay, so your assignment out of the book, 1-1, is going to be due Wednesday. I mean, I know some of those problems at the end you might not know how to do very well, but try to figure them out, and then I'll help you out with them. And also the problems on this worksheet. And I want you to try to get all those done and see what you can do there. So anyway, look forward to seeing you guys on Wednesday. Hope you'll work hard on this and do your best, and it will pay off. I'll see you on Wednesday.